Hey everyone, today I'll be going over an easy Leetcode problem, 461, Hamming distance. So basically, we're given two integers x and y, and we return the Hamming distance. The Hamming distance is the number of positions at which the corresponding bits are different. So in brief, just intuitively, say we're given this example here. If you actually look right here, these are their binary representations. So 1 is 0, 0, 0, 1, just like assuming the padding of zeros here. And then 4 is 0, 1, 0, 0. So at which points are they different? Well, they differ here. They're the same here. They differ here. They differed at 2 columns, basically. So, and the answer is 2. So we count the number of columns, you could say, where they're different. So the truth is, there's actually an operator for this. So if you actually know what XOR is, it's a binary operator, and it stands for exclusive OR. And basically XOR evaluates to 1 when the bits are different. So if we look, 0 and 0 is 0, 0 and 1 is 1, 1 and 0 is 1, 1 and 1 is 0, and this is XOR. So, or exclusive OR. So that's exactly what we need, right? We need to know the spots at which they're different. So how do we find if they're different? Well, the XOR should be 1. So I'll show you what we mean. So let's have a result, and this is going to be like our sum, our Hamming sum, I guess. And we're just going to go through each of these numbers, keep right shifting them, and then just XOR the rightmost bits, right? So we're going to go, while x is greater than 0, or y is greater than 0. So the reason why we do this is because, so take this 1 for example, right? If we right shifted this, it would become 0, but there would be still more bits we have to account for and 4. So we just need to go as so long as one of them's not 0 yet. So basically all we do is we simply add to res the XOR of the rightmost bits. So really, it's just like the XOR of two things, right? The rightmost bit of x, which we're going to do x and 1, and the rightmost bit of y, which is y and 1 here. So we do this because if you remember, anding means that it only evaluates to 1 if they're both 1, right? So if it's 0, this would be evaluate to 0. So doing and 1 is just a really quick way to get the rightmost bit. So we're going to XOR the rightmost bits, and the reason why we do the rightmost bits is because now we can right shift them. So we'll right shift x by 1, and we'll right shift y by 1. So right shifting just means literally, as you would predict, if you look at the representation, it just like shifts it over to the right. So this 1 would become 0, this 4 would become 2. So let's actually run this. And because I mean, we have to go like this, and writing it like this looks really funky, but this would be just like writing it as x is equal to x right shifted by 1, right? It's like the plus equals thing. So I'm just doing right shift equals. And then let's run this again. And let's submit. So yeah, 100%, so that's pretty good. Talking about time and space. Time is literally just O of n, where n is the number of bits in the integer, right? You could actually probably technically call it constant time because there's a max integer in Java, but we won't get into that. We'll call it O(n), where it's the number of bits, right? Space is constant. We don't use any extra space at all. So yeah, it's just constant. So yeah, hope this made sense. Thank you for watching.